go first time. All right. Okay, so this is a talk called Of Unicorns and Replicants. And if anybody here has ever seen a film called Blade Runner, then you're going to get a load of references, and if you haven't, then it's all going to go over your head. So this is me. By day I pen test, and by night I build little electronic hardware thingies, which you guys all have. So we're going to be over in the far corner over there. If you want to solder your badge together, if you've never soldered before, this is the badge for you. It's specifically designed so that if you're hungover, if you're useless, if you have no idea what you're doing, the worst case scenario is that you smell burning chicken. But it will work, and it's a really, really nice little tool. It's a bit like an Arduino. It's called Hidia. We had a Kickstarter running, which we finished a couple of weeks ago, and we're about to ship. So you guys have got everything before most of the Kickstarter backers. And this is maybe my 4th or 5th keynote now, so technically that makes me a thought leader. And this is a positive talk. You're going to hear a lot of negative things today. You're going to hear a lot of things where it's going to sound like the sky is falling and things are bad, so it's always good to open with a positive talk. And the topic of this talk is the state of IoT security. Or as I like to call it, this is fine. All right. But this is a positive talk. Okay, so the first question that we should ask ourselves is, did I actually test the headphone jack for the audio for this? I'm just going to quickly jump out and then make sure that this isn't putting the audio through HDMI. Okay, there we go. Cool. All right. So are we in a bubble? And I think to answer this, we should not look at what the commercial space is doing in IoT. Let's look at what the open source space is doing in IoT.
A while ago I made this motorized pen, and even though I personally think that this is a revolutionary design, some people point out that it doesn't really follow the trends of the industry. They say that it should be an IoT device with Bluetooth and a smartphone app to control it. Who am I to argue with Reddit, so we decided to give it a shot, and, well, have a look at this. It's absolutely bloody brilliant! Using a pen has never been this easy before. All you have to do is download and install the app, turn on Bluetooth of course, set up pairing with your device, and then, wait for it, and then you just swipe your finger. It's amazing. I'm sure whoever invented the pen intended it to work like this, and not with the silly button at the back. Still, I think we can do even better than this, by adding voice control. Now, the Siri in my phone doesn't seem to work very well. Can you open my pen, Siri?
What were you saying? I wasn't really listening.
So I took the pen and connected it to my laptop instead to use its voice control feature. Computer, open pen. Computer, close pen. Overall, I think we're onto something great here, and now I understand why all products have to be smart these days. It just makes all these items much more convenient to use. Thanks for watching. If you like this video, computer, close pen.
Okay. So, that's what the open source community is doing. And the easiest way to tell whether or not we're in a bubble as far as IoT is concerned is to identify products that are solutions looking for a problem. And to say, if there's maybe one smart pen on the market, then, okay, all right, things are probably reasonable. We're testing the market, we're maybe at the early stage of the curve. If there are a ton of smart pens on the market, perhaps we're in a bubble. So I went to a website called Top 10 Reviews, and these are the top 10 smart pens for 2017. So I guess we're in a bubble. And you might notice that there is one pen in particular that stands out, not because of its overall rating, but because of the fact that it's $1,115. Now, I don't know about you guys, but what I really look for in a pen is the ability to make permanent impressions on paper. Now, I can get that for maybe 5 of these for $1. So, for $1,000, my expectations are going to be pretty high. So let's see what the top 10 review site had to say about this most expensive smart pen, and they rated it 8.53 out of 10. And on the pros side, they said, well, it doesn't need to be paired when writing, meaning you can sync your notes later, because nothing annoys me more about a smart pen than a smart pen that stops writing because it's lost its pairing. And on the con side, it says, the smart pen makes an audible buzzing noise while writing. Now, for $1,000, I expect this to play deep, soulful music while writing. So, we're obviously in a bubble, and there's obviously really useless things being created. The question is, how did we get here? And in order to understand this, we have to go back. So, let's go back. Back to 1982. And in 1982, a bunch of guys at Carnegie Mellon University had some really great ideas, and this was not one of them. They had a Coke machine in the hall, and they wanted to know, before they get up to go and get Coke, whether or not there are Cokes in the machine. So they built a system of micro switches and put them on the bottom of the Coke machine tray, and that way they hooked it up to a PDP, and they could finger it across the internet to see whether or not there was Coke in the machine. And this is the first recorded IoT device. The second device was a coffee machine, which eventually, refinements of that led to the Internet Coffee Protocol. But things have progressed a little bit from that. And in 1985, Peter Lewis, at an FCC session, came up with a very long-winded definition of what he called the Internet of Things. And basically, he defined it as the integration of people, processes, and technology with connectable devices and sensors to enable remote monitoring, status, manipulation, and evaluation of trends of such devices. And I like to think that Peter Lewis was very hopeful about what the Internet of Things would become. Perhaps misplaced in that hope, but I like to think hopeful. And if you look on the left, what you can see here is we have a typical Internet of Things device, which is an LED scrolly thing for dogs. Now, you may notice that it says here that when your dog wanders away, lost mode is activated. Now, looking at the position of that jacket, if your dog could read, I'm not sure it's going to know that it's lost. You, on the other hand, are not going to read that sign if your dog's lost. So, you know your dog's lost because it's not there. Your dog knows it's lost because you're not there. You don't know where your dog is. Your dog doesn't necessarily know where it is, it smells like butts. And thus we have this whole issue of things coming out where basically they're kind of the hold my beer of product ideas. Speaking of the hold my beer of product ideas, this is one of the first consumer IoT devices, the LG Dios fridge. And what they did was they took an $800 fridge and they thought, how can we make this $10,000? And they had a genius idea. What they did was they took a 15-inch web pad, glued it onto the front, wired it up to an Ethernet connector with a stylus, and put a digital camera on there so you could see the inside of your fridge by walking up to your fridge, taking the stylus out, tapping through a bunch of menus to bring up the webcam app, and then you can look inside your fridge. It's a great idea and totally justified the $10,000 price tag. And for a long time, a lot of IoT devices just kind of were things that were ordinary with a sensor bolted on, and then something magical happened. And by magical, I mean horrifying. Kickstarter came along in 2009. It is the perfect intersection of people who have never made a product before and people who have never invested in something before. And having finished a Kickstarter, I can tell you it's an incredibly surreal experience. But effectively, there's problems everywhere. So let's have a look at what Kickstarter thinks about the smart pen industry. The fact we have a smart pen industry causes me a bunch of despair. But this is a positive talk. We can see that we have a bunch of different devices. Lots of things are the world's first. On Kickstarter, everything is the world's first. There were several world's first smart pens. And also on here we have some world's first smart paper and pen notebooks. And we also have some stuff that's actually not so bad, like a smart e-paper notebook thing that you draw on. All of which, solutions looking for problems. So the fact that we have these IoT devices that have these functional issues in that we're not really sure what problems they solve and we're not really sure if they're actually worthwhile leads to a situation where things get an initial amount of funding, you're trying to ship a product, but the follow-on from that, there's no real incentive to make it secure. And this leads to a bunch of problems with IoT devices. The first of which is botnets. So we've all heard of Mirai, and there are similar botnets, but we can't really blame IoT for the existence of Mirai, and the reason for that is that Mirai would have happened anyway. The fact that we have a bunch of insecure devices on the internet is not new. It's simply the scale of these devices. But if it wasn't this, it would be something else. It would be WannaCry. It would be something else out there. So when you see all of this stuff in the media, don't let it get to you. This is just noise. Look for the signal. Another common problem with IoT is endpoints. So I'll give you an example of an endpoint that's serious. So there are minor endpoints. For example, there's a webcam that every year at 44Com, which is a conference I co-organize in London, we get submissions for the same internet webcam. And the webcam itself is hideously insecure, but I broke it in 2009 and it wasn't new then. And it's an OEM that produces the same webcam, and you can spot it's the same webcam because it has telnet or SSH or a web service with a remote code execution bug or a heap overflow and a buffer overflow in the same URL path and a root password of 123456, which is conveniently stored in read-only memory. So, that's a common thing that happens and it's not going away. And that endpoint will still be there in 20 years from now. But when your webcam gets hacked, it's not necessarily the end of the world. You can get a new webcam. On the other hand, when your pacemaker gets hacked, that's a different issue entirely. So when we're told that the sky is falling when it comes to IoT, realistically, we shouldn't care about the webcams of the world so much. We should that's noise. Just don't worry about it. It's something we have to live in. It's the world we live in now. It's like Donald Trump. But when a pacemaker goes wrong, that we need to care about. So St. Jude Medical is an interesting company. I went to their website and they had a company facts page. And I don't know about you guys, but whenever I see a company that has a dedicated page to company facts, I smell bullshit. So they had a really interesting thing going on. They weren't actually doing so well financially in some areas. And they'd been in talks to be acquired by another company. And then a third party, somewhat presciently named Muddy Waters, hired a medical security specialist to go and have a look at St. Jude Medical's stuff. So said researcher had a look at the stuff, produced a report, passed it back to Muddy Waters. And Muddy Waters' business model is this. They find companies that they think might not be doing so great or might have skeletons in the closet. Then they bang the drums about the stuff in the closet after they've opened a short position. And then they wait for the stock price to go down, and then they close out that position and make a ton of money. That is their business model. So these are not exactly the nicest guys in the world. The security researchers, on the other hand, totally cool dudes. So they get asked to review this thing called Merlin at Home, and, sure enough, they produce a report which Muddy Waters then release, which is somehow strangely hard to find as a result of various accusations and potential lawsuits. But I've got it anyway, and it's quite an interesting read. And basically, they rooted the device that configures the pacemaker. So by modifying the device that configures the pacemaker, you can modify the pacemaker. The interesting thing about this wasn't necessarily that Muddy Waters were deliberately doing this to screw with the stock price of St. Jude Medical in the middle of an acquisition.
the interesting thing is St. Jude's reaction. Their CTO said that the claims were absolutely untrue. Now, I don't know about you, but I trust a screenshot of a hash prompt more than 90% of other things that I trust. So the FDA, the Food and Drug Administration in the US, got involved. And then, strangely enough, after getting involved, they actually figured out that, yeah, okay, so the pacemaker can be modified to give out shocks when it shouldn't, or deplete the battery, or change the pacing so that it's inappropriate, or any number of really bad things. So we now know that it's true. We also know that the CTO made false statements in the middle of an acquisition. And things went wrong. And later on, when they started to patch and update, they sent patches out across their Merlin at Home network, and they put out this weird statement saying that they continue to lead the way in advancing cybersecurity protections. It's an interesting definition of the word leading the way. But they said that all medical devices using remote monitoring are exposed to the risk of potential cybersecurity attack. Fair enough, true. Not all of them actually allow you to change the pacing and deliver electric shocks. And they said that they're not aware of any cybersecurity incidents, which of course is a perfectly rational thing to say if you believe that absence of evidence constitutes evidence of absence. But ultimately, the lesson that we have to learn from this is that the FDA realized at that point that this stuff affects them. The FDA signed off on pacemakers that could be hacked. So this happens in incredibly critical and sensitive environments where patching is not necessarily an immediate thing due to certification. And that's the kind of stuff that we need to worry about with IoT. The bulk of the stuff isn't really an issue. Another problem that we get with IoT is overreach. And I'll give you an example of a company that has a big problem with overreach, and it's a TV maker, and it's not Samsung. They have a small problem with overreach by comparison. So Vizio are the US's largest LCD TV seller by volume. And I can tell you now, they did not get to where they were by making really fantastic LCD TVs. What they made was cheap LCD TVs. And as smart TVs started to take off, they developed a smart TV platform. And in their platform, what they had was they used advertising to supplement their revenue, which would then allow them to reduce the price of the LCD TVs. The margins on TVs are really tiny. They're really razor thin. So they're constantly trying to innovate in ways that they can tell you, make this TV better than the other TV that you see next to it. So what Vizio did was they developed a thing they called Smart Interactivity, which was deployed across 10 million Vizio smart TVs. And what that did was monitor everything you're doing and send it back to the mothership. So far, so not so abnormal. Let's see what the Chicago Tribune had to say about that. All right, let's not see what the Chicago Tribune has to say about that. Let's see what that partisan blog of the Federal Trade Commission has to say about that. You know you're doing badly when your regulator has to post a blog post to explain just how messed up you are. So, on a second-by-second basis, bearing in mind this is from the FTC, this is their regulator saying this. On a second-by-second basis, Vizio collected a selection of pixels on the screen that it matched to a database of TV, movie, and commercial content. They captured as many as 100 billion data points each day from millions of TVs. Now, that's not the worst thing that happened, because what happened was they provided consumers' IP addresses to data aggregators, who then matched the address with individual consumers and households. The contracts stopped them re-identifying by name, but they could identify by household, they could identify by sex, age, income, marital status, household size, education, and home ownership. And this was not anonymized. And they got away with it. And the thing about overreach in the IoT space is that the data is the biggest money maker that there is. When you get an IoT product that does something useless like a smart pen, Everything that you do with that smart pen, that data is recorded. And the people who make it have to look at how they make money to support the services off the back. And the main money maker, par none, is to send data to the mothership and sell it for advertising. So these guys, ended up tracking people individually and provided that to other advertisers to track individually. But, overreach problems are rarely publicized, but there's a lot of them out there. And this is something that we should be concerned about. And the final IoT problem, which is not unique to IoT, in fact, the airline I came over had an availability problem this weekend, is availability. And to demonstrate availability, I'm going to show you an advert for a real IoT product. Now, I thought that the advert was a little bit boring, so what I did was I just overlaid some information on top to keep things going. So this is not the authorized advert, and under fair use doctrines, I have tweaked it to make it a little more interesting to watch.
It's not easy being a dog. The waiting, the uncertainty, the hunger. Mainly the hunger. I hope he remembers to buy dog food. I can't believe he's working on a Saturday. Don't people need weekends anymore? I just hope he gets here soon. I can smell every meal being cooked in the building and beyond. I can smell the food truck down on the corner. I don't think you humans know how difficult this makes it.
I'll email when I can.
What could he still be doing out there? In the past, I would have started chewing on shoes or going through the garbage, but that's not going to solve the problem, and I'm determined to find a solution. After all, we live in an age of high-tech gadgets. Surely someone has thought of this. The PetNet Smart Feeder. Feed your pet while you're away. It precisely measures portions based on your pet's age, weight, and level of activity. All effortlessly controlled on your phone via the PetNet app. Then my work is done. This is the answer. You look exhausted. Just want you to know, I totally know how you feel. I had a busy day myself. All right, let's see if he notices my amazing research skills.
Did you do this?
He did. It's more beautiful than I could possibly have imagined. No more waiting, no more uncertainty. It's pretty great to be a dog sometimes. The PetNet Smart Feeder. Healthy pets, happy owners.
Okay, so those one-star reviews, they're from the product page on Amazon. That's just the first set of reviews. You go through these reviews and it's a dumpster fire as far as the reviewers are concerned. And I can't help but feel that part of that is because bits of plastic keep coming off the kibble feeder and choking pets. But that's not an IoT problem. So let's talk about the IoT problem that PetNet had. Now, PetNet is not the only IoT provider to have a problem, but there was a fundamental flaw with their product, aside from choking pets, which is that they had an outage for 10 hours. Now, when they had that outage, because the PetNet feeder connects back to the mothership, it could no longer do so. And that meant that it didn't feed pets, which is pretty tough when you had one job, PetNet. One job. Just feed my pet when I'm not there. I like to think that's why this guy is sat with his pet by his feeder, making sure that this thing's actually doing the job it's meant to do. But, nobody likes headlines like cats, dogs starve as web-connected chow shoot PetNet plays dead. But for $149, realistically, when you can buy a 12-serving feeder for about $50 that works on a timer instead, it's a bit of a letdown. So the fundamental problem that they had and what they needed to do was obviously make it so that it connects to the mothership periodically and then has a built-in real-time clock that can say, okay, At this time of the day, just put the food out. Try not to get bits of rubber in there. And even in the reviews, which were glowing, there were problems. So this review was one that I found, it was one of the first reviews I found just Googling it. And one warning that alerted me that Felix missed a feeding. This was the result of the smart feeder's battery dying. Sadly, it was not preceded by any low battery warning that would have given me a chance to recharge. You would think that they would have resolved this issue, but no. But still, when I let the food hopper run out completely, I got the usual notifications that Felix had been fed. PetNet says a couple false positives might register when the hopper runs dry, and it's tightening up this functionality. So, there are functional issues above and beyond the availability element of this product. And it's not the only device that's a smart device. But I guess what I'm trying to say is that some of these problems are not entirely limited to the scope of the smart element of the device. And sometimes the IoT just is not good. So the question I'd like to ask is there such a thing as good IoT from a security perspective? What good IoT is out there? And the answer to that is yes. But you might not think of it as IoT. So if we exclude mobile phones, because mobile phones are the perfect example of a good IoT device. They are the intersection of sensors and data and human interaction with the internet. They are, in effect, the thing of internet. The Oyster card is a transport card used by Transport for London in the UK. And it's been running for years and years and years, and it's been battle-hardened over time. Now, it's not without its flaws, but it has a mature program for management. That makes it a good IoT device. Payment systems, physical payment systems like Apple Pay, where we have tightly regulated environments that properly control data, they are good IoT devices. If we look back at St. Jude Medical, that's a regulated environment where the regulator lacks maturity from a security perspective, but they will get it right, and when they do, things will start to improve. They just have to figure out how that's going to work. Wemo by Belkin is an example of a product that's had so many bugs, so many problems. The Wemo Belkin switch has been hacked 7 ways from sundown over a period of years, but they have a mature product now, and it's getting better. And the final thing I want to show you, which is just a picture of a map up there, is Orion. So Orion is a really good example of in-house IoT. Orion is the UPS system for sending out trucks on routes with a minimal amount of distance coverage. It's a way of resolving this traveling salesman problem. And what makes Orion so good is that it's a primary focused piece of IoT that is focused on delivering something that works. And I can't speak much for the security of the thing because that's not public information, but it is saving UPS a hell of a lot of money and a hell of a lot of carbon emissions as well. So if we have good IoT and we have bad IoT and we have downright humorous IoT, we can say that the good IoT is what we would call the unicorns. And we would say that the bad IoT that's lagging, that's copying the failings of unicorns past, are the replicants. And we can ask ourselves, what does leading IoT look like today? And the way it looks like is that normally you have 6 parts to a piece of modern IoT. You have an end device, which may be an individual sensor on a sensor network with a hub over a wireless protocol, or may just be a device itself that connects via Wi-Fi or Bluetooth and speaks over a communications medium. And that speaks to a comms service. And the comms service is separate to everything else. It's a broker. And what the comms service does is it takes the stuff coming in and then redirects it to the relevant internal service. There's a management service which is normally accessed through an application on the phone or on a web page, and that allows people to go and manage their device, their thing. There may also be back-end systems as part of that management device that allow the inventors or the owners to go and manage the data that's coming through. And at the back end, disconnected from all of that front end, you have that sweet, sweet money mining data. Again, going from the comms service, you should have a physically separate maintenance service, and that's a system that provides updates, management, telemetry, stuff like that. And again, that connects to the sweet money mining data capability. And then it kind of all looks like this, with most of it in the cloud. By contrast, what do replicants look like? Well, yeah, nowhere near as organized. In fact, you could say that if the leading edge is well organized and structured, then the trailing edge is kind of just doing it on the hook. It's kind of just like, we don't know. We're just kind of, yeah, whatever. We got a Kickstarter going. Which leads us to the question, are things getting worse? And I know so far this talk has not been as positive as I might have initially hoped. But to answer that question, we have to go back to 2005. 2015, rather. And in 2015, this is what leading IoT looked like, which is kind of more like this. Yeah. Except it was more like a cascading set of dumpifiers in kind of dumpifiers in a Matryoshka doll type configuration. So this is a very fast-moving target. And in 2015, what we had immature cloud platforms that these things were based on. So things like AWS, Azure, they weren't quite fully matured. HANA Cloud Platform, IBM Bluemix, they weren't even around. These days, we actually have mature cloud platforms that are not just from the cloud providers. We have IoT cloud platforms from providers like Electric Imp and Particle. There was very little by way of open guidance. I actually did a closing keynote at AppSec EU 2 years ago in 2015, and that was actually partly about the OWASP IoT project, which had only just got off the ground. And there were these unrealistic expectations, because everybody was told that IoT is going to change the world. And if you believe that a smart pen that costs $1,000 is going to change the world, I have a smart bridge to sell you. And when it comes to the maintenance systems, there was very little guidance in 2015. But partly because there's been so much development in helping people package stuff from an open source perspective and distribute, you now have a lot more ways to do code signing, a lot more ways to do distribution and delivery over things like even just GitHub. We now have more secure distribution frameworks, and the IoT cloud providers provide distribution updates that are signed, that are properly managed. In 2015, we had very little guidance on maintenance, and now we have lots. Back in 2015, there were web/native mobile apps. So you would have, in your code base, you would have an iOS app. And the iOS app would have separate code subbases for the iPhone and iPad. You would then have separate code bases and separate subcode bases for Android, Android phone, Android tablet, possibly Android TV, and Android whatever the hell we can piggyback off this week to get PR. There would be disparate forms of connectivity, so people would be reliant on random RF modules, and they'd let the RF module decide what's going on, and the microcontrollers were kind of like, we can't handle encryption. Encryption is too intense for us to actually do. There would be things like USB serial interfaces or physical Ethernet jacks for stuff. So it's all disparate, and nobody really has a standard. Whereas just 2 years later, what we have now is we have fairly unified frameworks and paradigms for management apps, which consist of, granted, Cordova, PhoneGap, things like that. So we're wrapping it in a web UI, and then we build a bunch of apps off the back of it. But it's a known attack surface rather than an unknown attack surface, and we have common connectivity with BLE and Wi-Fi. Zigbee is on its way out. We have LoRaWAN for long-distance stuff in, say, something like the control system space. But most of the stuff that you see, especially consumer IoT, is going to be BLE and Wi-Fi. Our comms services would use proprietary protocols or half-assed implementations of HTTP. Back in 2004, I worked on what could be considered a predecessor of the type of thing to UPS's Orion project. And the guys who built the kit, one of the guys who built the software, which was based on Windows CE and a Pocket PC, actually wrote his own web server because it was the first time he'd ever done a web application. And he's like, how do I shut web? Wrote a physical HTTP server that integrated all of the actual paths and everything in, and all of the application elements, because he needed an application server. So, and this was the norm for IoT. In fact, it still is in some areas. And it would grab data all the time, because when you've got guys in Silicon Valley coming up with new ways to spin money out of stuff, they have excellent connectivity. If you go to South Africa, or if you go to even places like Australia, the connectivity is not the same. So grabbing all the data all the time is going to saturate your connection. Whereas now, what we have is standardized protocols. You know if you're an IoT developer that you're either going to use some sort of JSON-type serialization, and you want to abstract the actual protocol from what you're doing if possible, so it'll be HTTPS, but you want to have some sort of standardized approach with an API. And then if you want to do pub/sub, you're either going to use something like Mosquito, or you're going to use something like RabbitMQ, or some sort of message queuing system. And what we have now is, instead of grabbing all the data, we only have IoT manufacturers grabbing profitable data, because they realize they have to pay for storage, which is still too much, but it's progress. So the other thing to consider is that in 2015, our comms mediums were mostly unencrypted. So everything would be HTTP, and if you're the kind of person who's totally worried about Five Eyes, one of those paranoid dudes, you know, not like most British people, we don't care, that everything that we do is monitored and everything that we do is watched. If you're one of those people that's annoyed by such things, you might think, before you buy an IoT device, could somebody take over this by intercepting the traffic? And for most stuff, it was like, yeah, you can deliver your own custom firmware and update the device, because there's no integrity checks. And the thing is that we expected these things to be secure because we were being told that they changed the world, but we never specified how. We never specified what the requirements for security were. We never specified what constitutes security in these devices. And that's because there were a lot of unknowns. Whereas now what we have is we have microcontrollers that support crypto in the hardware. We have security baked into the silicon with things like Trust Zone and with some of the work that's happening in the Sci-5 area. We have integrity checks at the transport level. We have integrity checks at the code update level. That stuff is now available in the IoT frameworks. And that's all because we've set expectations.
Volkswagen, das Auto.
Another 100% certified emissions test pass from an end device. Our end devices were terrible in 2015. They would have telnet interfaces left open. It's one thing to leave test points in a UART on the board. It's another thing to have telnet open and UPnP configured to map that to the internet. But these days we don't. We have less of that. That webcam, that OEM webcam that we get submissions for every year is still out there, still forwarding telnet, still opening that up to the internet with its route 1, 2, 3, 4, 5, 6 over UPnP. But the modern stuff, people have realized that it pays to not have your telnet port open. We're improving the hardening, so we're starting to see more capable microcontrollers. We're starting to see capable microcontrollers that have concepts of trust put forward in a way that IoT developers can understand. You might think of trust as, please don't look at a tiny corner of my TV screen, watch what I'm doing, and send it back to the mothership so that you can sell me a better class of porn. But when I say trust, I mean the code executing is verified. We can verifiably say that it's watching stuff to recommend better porn. And we have limits and expectations set more appropriately. So the question that leads to is, are things getting better? And I believe that they are. And IoT isn't my first rodeo. It's not even my second rodeo. I'm jaded and cynical for a reason, and it's not that, I'm some green dude off the strip. But because this is a keynote, I feel it's obligatory to introduce a Gartner chart. And this is Gartner's hype cycle. I'm not sure where Gartner sit in this hype cycle, but IoT is no different a technology or anything else. And what we have is at the start, from left to right, we have a tech trigger, the initial spark, that Coca-Cola machine at CMU. Then we reach the expectation peak, which is somewhere around 2015. The hype cycle was at its most. This is going to be revolutionary, change the world. Let's have every 20-year-old who's dropped out of university some funding, and then they can pretend to be the next Steve Jobs sort of stuff. And now we are skiing wonderfully down the piste of the despair trough. Again, this is a positive talk. But we're going to come out of that onto the slope of enlightenment, as Gartner call it, into the productivity plateau. We will get there. Things will start to get there. We're improving already. We're starting to see changes in silicon, changes in platforms. We're starting to see consolidation. Things are getting better. And another cycle that I could use, or another chart that I can show that has no numbers on it to make my point, is the meter maturity cycle. So meter is a standards organization, which lends what I'm about to tell you some credibility, despite the fact I have no numbers on the chart. In 2015, we had immature technology, and there was very little experience in dealing with the fallout from this technology within people who work in the functional areas of the IoT space. And that's when we encounter a new technology, that's how we have to look at it. We cannot assume that there are a bunch of security people there by default. And we have to look at those guys and go, if we have the equivalent of guys who've just learned how to make a PHP page, and we put them in charge of a Volkswagen safety system, who's going to tell them how to do security? Because if nobody does, then what we're going to get is that emissions test. Whereas if we tell them how to do it right, we'll never know about that emissions test. So in 2017, what we have is that improving tech and experience. And Meter says that there's a new technology point where the maturity is at its lowest. Makes sense. And then it improves and it becomes mature. And as it becomes mature, what happens is that new things pop up within the technology that make it so that the maturity dips. So we can see this in web applications, for example, where a new class of vulnerability appears, but it affects a subset of technologies rather than the whole piece. We haven't really had anything major on the scale of, say, SQL injection for a long, long time with web application, and that's because web application security is an understood problem, and there are solutions available for dealing with the problems that are understood. And now I'm going to do something that you should never do with a chart, which is superimpose two unrelated things on top of each other, but this is a keynote, and I can get away with that. So if we look at the two unrelated chart items there, we can see that actually there is, if you think about it, some element of I wouldn't say correlation, but similarity between the two. We know that when a technology is young, that it's immature. That's obvious. We also know that hype picks up while the technology is immature. So by the time we hit that piece going down to the despair trough, we are ragging on an immature technology. So when you see people going, hey, I rooted this webcam, I rooted this baby monitor type thing, basically what you're doing is you're punching a 5-year-old and stealing their lunch money. It's not exactly busting open Chrome on Pwn to Own. And that's realistically because these things haven't matured. So over time they'll improve, and over time it becomes harder to exploit, and people will move on. And then what I'm going to do is I'm going to do something that is typical of a keynote. I'm going to stick my name on something, and I'm going to call it Lord's Observed Security Megacycle, because I couldn't come up with a decent backronym that was quite rude, that involved swear words or something. So we're just going to have to make do with LOSM. And basically what we have is we have the hype train at the left. That hype train leaves the station. We have security expectation hits a peak because we ride off the back of a bunch of marketing material. And we should be suspicious, but it's just so shiny. It's just so shiny, and it's going to change the world. And then just as we start to understand the problem space, the hype train derails and smashes into everything, and suddenly black hat. And what happens is, with any new technology that's actually got a serious hype train behind it, come black hat, come conference season, you're going to see tons and tons of stuff about this technology is dreadful. This technology should be encased in concrete like Chernobyl, and we should just pretend it's not there. This is the Fukushima of that technology. I made an IoT webcam drive on the highway and stopped it remotely, with a journalist inside the webcam. You're going to see all this stuff come out. And that's because it's a natural progression of understanding the shape and size of the problem space. Now what happens is that first year around that cycle, we start to understand the problem space. People come back from Vegas and start going, man, my head's sore. Some guy said some crazy shit about a webcam. And they start working on solutions to the problems. But these are point solutions for point problems. We understand parts of the solution space, but we don't understand the whole. So we iterate through this and we go back through, and then eventually these things consolidate into a bunch of products that are just as bad as the very products were in the first place. Security to protect you from WannaCry. Anybody see any WannaCry adverts? Seriously? What kind of industry do we live in where people just ambulance chase like that? It's not like it's an unknown problem. It's not even like it's an unknown solution. The patch had been out for months. There is nothing you could sell me that would resolve WannaCry that can't be achieved with WSUS. So, a new technology appears. And then, because of problems, we might say it threatens the original inventors in some way. And ultimately, there are problems that threaten the safety and viability of its users. And then what happens is these point problems meet point solutions. But not all these solutions are the right solutions. They're point solutions, not the whole thing. And not all of the iterations that come out survive, not all the solutions survive. So what we do is we manage the problem space, we manage the individual point solutions, and then we go and pull that together to create a single set of solutions that are consolidated. And you see this with every technology. You will look and you'll see there's leaders and individual point elements, and then there's a period of consolidation. In the UK pen testing industry, for example, we're undergoing a massive period of consolidation from pretty much hundreds of providers down to a smaller number. And that's how companies like NCC exist, through acquisition, and other companies as well. They reach a point where they can't grow anymore, so they have to acquire. And that consolidation in the marketplace leads to a concentration of expertise and a concentration of failure. But we've been here before, and the best example of this is Web AppSec, where because we understand the problem space and the solution space, we can say it's mature, and new things will pop up and challenge us in any technology space. But they become point problems when we have a consolidated solution. It becomes business as usual, trying to resolve them. So unicorns and replicants share some qualities, and realistically, we should welcome their failures. They are telling us what not to do, and we shouldn't fear them when they happen, because individual devices tend to have a short lifespan, and sometimes the memories that they give us are really all that we have. But even then, after a while, when you think about it, all these moments will be lost, like tears in rain. So I'd just like to say, when you're looking at this stuff today and you see all these bad things, remember the positive, but go out and have a go at some of this stuff. And when you identify failings, you're actually helping people. So it's time to hack. I've been Steve Lord. Thank you very much.
Thank you, Steve. Thank you. That was amazing. So, do we have any questions from the crowd? Raise your hand. Any questions? This might be a good time to mention that the best audience question this year wins 2 tickets to 44Con, courtesy of Steve. So give him a round of applause for that. So I think we have one down here.
Have been talking a lot about Internet of Things and the software that is running on it, and about hardening. I wanted to ask you one question. You might know about a project called YearSec, or Year Security, that tries to make a hardened Linux kernel. And one of the problems that it has is that since it's GPL software, you have to provide the sources for that hardened kernel if you want to distribute the kernel inside the Internet of Things devices. Do you think projects like YearSec that have more open licenses will arise at some point of time?
It's a tough one. So am I right in saying the question's about more open licenses and open source in IoT? Yeah, so.
Yes.
Yep. So there are open source platforms and platform elements out there. There's very little incentive for IoT providers to use open source because you're in effect giving away the secret source. So has anybody ever heard of a thing called NomX? It is the most secure email solution in the world. There is no email as secure as this. And a UK blogger, typical UK blogger, who does nothing all day but monitor things like SSL and TLS deployments and stuff and help people secure them. A UK blogger. He went and had a look at NomX, and then he took their proprietary product based on a Raspberry Pi and pulled it apart. And that's all their secret source out now, just because of that one UK blogger. So there's no incentive for these guys. There's a huge incentive for charlatans to go and hide and obscure this stuff. And IoT, in many respects, is just an extension of two kind of other technologies, the embedded space and cloud, and neither of those have been good actors as a whole in terms of open source, and they need to try and open things up. The only way we can really do that is by force. So, you know, the badges that you've got, we're releasing the source at the end of next month because we're required to, because we use the VUSB library, which is GPL, and we have to provide the source for all of our stuff, including our hardware, as a stipulation of their license, and rightly so. And I think, yeah, if we had more examples of what went wrong because we have more open source, we can definitely find better answers to some of the problems.
All right. Sorry about that. Let's see, any more questions? You got a hand over here? Here we go.
You talked about a lot of vulnerabilities in all the IoT stuff. Have you built any into the badge? For learning?
All the bugs are things that you add yourself.
All right, let's see, here we go. Sorry.
Thank you for a great talk. You mentioned the short lifespan of the devices, but looking at like pacemakers, what would you say is the status of IoT or connected pacemakers, and when would you put the pacemaker or accept a connected pacemaker in yourself?
That's an interesting question. So when it comes to pacemakers, as I understand it, they have quite a long lifespan for the devices, but one of the things is that their firmware doesn't have a huge amount of lifespan by comparison. I think you can expect the pacemaker's firmware to be updated periodically, and that's really down to the regulators to find out how often that should be. Personally, going back to the earlier question about open source, it's an interesting quandary that's created. I'm not really sure that I want to be able to run my own unsigned code on a pacemaker that is inside me. I mean, I don't know you guys, but every time I declare a variable, I'm pretty sure an angel dies. So, you know, it's an interesting quandary, but yeah, I think probably you're looking at maybe sort of 10 to 20 years for the lifetime of a pacemaker, but the software itself will get updated more regularly.
All right, let's see, anyone else? Again, there's 44Con tickets on the line, guys. All right, I think that's all. Oh, I have one question over here. That'll be the last one.
Great talk. My question is about, do you think we as a security community will actually handle this problem, or do you think lawmakers will get to us first?
So that's a very interesting question. When it comes to web security, do you think that we got there first, or do you think PCI DSS did?
I don't think we fixed that problem yet either.
Oh. I think that realistically, probably our best chance is to provide guidance and then for lawmakers and regulators to mandate compliance with some sort of baseline standard. I think the mistake that we could make is by making those baseline standards low enough for for the manufacturers to continue to limbo underneath and get away with it.
All right, that's all the time we have for questions, but while we do have you on stage, Steve, I was wondering if you could show us and tell us a little bit about the badges that you should all have in your giveaway swag bags.
Okay, so earlier this year, well, for the last year and a half, I've been working on a project called the HIDIOT, the Human Interface Device Input-Output Toolkit. And I've been working on this for quite a while now, and basically what it is, it's a bit like an Arduino, but you build it yourself from the ground up. You solder the parts. We've got soldering stations and bits and pieces over there. It also has a unique property about it in that it can emulate any USB HID device. And it's not really that unique, but it's just really easy to do. So if you consider things like USB rubber ducky attacks and things like that, it's quite easy to implement. It's not as powerful as a USB rubber ducky, but it's extendable. So a couple of weeks ago, I plugged in a BLE module, wired that up, got that working. So I then had a BLE-controlled USB rubber ducky. I can't imagine what people would want to use that for, but you know, you could do things like plugging LoRaWAN modules on to use it from distance, or you can just do things like, we've got some examples of stuff where we've got scrolly messages and blinking lights and stuff that you can do as well. And the main thing isn't to make it a really cool badge, it's to make it so that the barrier to entry is low.
But it is a really cool badge.
Thanks. But things like the board's extra thick, it's really hard to damage the board and the components. You can assemble this if you've never soldered before. You can assemble this if you are hungover. You can assemble this if you have the flu and the shakes, as one guy did at Hack in the Box a couple of months back. There is literally nobody in this room who will struggle with it. And your biggest number one risk is that you smell burning chicken. In which case, just put the soldering iron down and then give it a moment and start again. So there's really no excuse to not put these things together, and especially if you've never soldered before, it's really easy. It's what it's designed for.
Fantastic. All right. Another round of applause for Steve, please.
Thank you.